Understanding GLP-1 and GIP medications. How they work. GLP-1 receptor agonists are a special type of medication. They work by copying a natural hormone in our body. This hormone is called glucagon-like peptide 1 or GLP-1. When these medications mimic GLP-1, they help our bodies in important ways. One key action is stimulating the production of insulin. Insulin is vital for controlling blood sugar levels. These drugs also send signals to the brain. These signals tell the brain that we are full. This feeling of fullness helps to reduce hunger. Common examples of these medications include liraglutide and semaglutide. Dulaglutide is another example. They are mainly used for people with diabetes to manage blood sugar and appetite. Another important group of medications involves GIP. GIP stands for glucose-dependent insulinotropic polypeptide. GIP receptor agonists work in a similar way to GLP-1 agonists. Their main job is to help promote the release of insulin. This insulin release happens after we eat food. This is very important for managing blood sugar levels effectively. So when a person eats, these medications help their body respond correctly. They ensure that insulin is available to process the sugar from the meal. This helps keep the body's energy systems balanced. These medications are part of a growing family of treatments for metabolic conditions. There is also a medication called tirzepatide. Tirzepatide is interesting because it acts on two types of receptors. It works on both GLP-1 receptors and GIP receptors. This dual action makes it quite effective. The Food and Drug Administration, FDA, has approved tirzepatide. It is approved for treating type 2 diabetes. Many doctors also use it off-label for weight management. This means they prescribe it for weight loss even though that is not its primary approved use. The ability to target both pathways offers a powerful approach to treatment. This dual approach can lead to significant improvements in both blood sugar control and weight reduction for many patients. So, to summarize, these GLP-1 and GIP medications are primarily designed for specific tasks. Their main goals are to help manage blood sugar levels in people with diabetes. They also play a significant role in controlling appetite. By signaling fullness to the brain, they can help people eat less. This leads to better weight management for many individuals using these drugs. Their effectiveness in these areas is well documented and has made them valuable tools in modern medicine. However, as we will see, their effects might reach further than originally anticipated, opening up new possibilities for their use in other health concerns. A surprising link: medications for diabetes and addictive behaviors. Recently, an unexpected connection has emerged. People taking GLP-1 and GIP medications have reported interesting changes. These are medications like semaglutide and tirzepatide. Some individuals have noticed that their desire for addictive substances has lessened. This includes cravings for things like cigarettes or alcohol. Others have found they are less interested in compulsive behaviors. These behaviors might include excessive shopping or even habits like nail biting. These are anecdotal reports, meaning they are based on personal experiences. However, these stories are becoming more common and are sparking scientific interest. Because of these reports, scientists are now investigating this link more closely. They want to understand how these diabetes and weight loss drugs might affect addiction. It is a new area of research. The initial observations are primarily from patients sharing their personal journeys. However, the consistency of these reports suggests there might be a real biological effect at play. Researchers are curious about the mechanisms involved. They are designing studies to explore this potential connection in a systematic way. This scientific exploration is crucial to determine if these anecdotal findings can be substantiated by rigorous evidence. The early thinking is that these medications affect hormones related to satisfaction. We know they make people feel full after eating. This is due to their impact on satiety hormones. It is possible that this effect on satisfaction extends beyond food. It might also reduce the strong cravings people experience for substances like alcohol or nicotine. If the drugs can dampen the reward feeling from these substances, it could make them less appealing. This is a promising hypothesis. It suggests that the body's reward system, which plays a big role in addiction, might be influenced by these drugs. The way these drugs might work on addiction could be through brain chemistry. The current hypothesis suggests they might change how the brain processes rewards. Addiction often involves powerful reward signals in the brain. These signals make people want to repeat the addictive behavior. GLP-1 and GIP medications could potentially interfere with these signals. This interference might make addictive substances or behaviors less satisfying. If the reward is diminished, the motivation to seek it out might also decrease. This is a complex area, but the possibility of altering brain chemistry related to addiction is very exciting for researchers. Scientific Clues research on GLP-1 GIP and addiction. Early scientific studies are starting to provide some clues. One interesting study involved rats. In this research, scientists gave semaglutide to rats that were conditioned to consume alcohol. The results were quite revealing. The rats treated with semaglutide showed a reduction in their alcohol consumption. The study suggested that the medication worked by disrupting the reward mechanisms in the brain associated with alcohol. This means the drug might have made alcohol less rewarding for the rats. Animal studies like this are often the first step in understanding how a drug might work in humans. They provide valuable initial data. Following up on animal studies, research involving humans is now underway. These human studies are essential to see if the effects observed in animals translate to people. For example, the University of North Carolina is conducting a notable study. This particular study is looking at how semaglutide affects alcohol consumption and cigarette use in humans. Researchers are carefully monitoring participants to see if the medication helps reduce their cravings or their actual use of these substances. The outcomes of such human trials will be very important. They will help us understand if these drugs can be a safe and effective tool for addiction. It is very important to remember that this research is still in its early stages. While the preliminary findings from both animal and some early human observations are promising, we need more information. More extensive and larger-scale research studies are absolutely necessary. These studies will help us draw definitive conclusions about how well these medications work for addiction. They will also help us understand any potential side effects or limitations. Science takes time, and careful study is needed before these drugs could be widely recommended for treating addiction. We must be patient and allow the scientific process to unfold. These ongoing studies are incredibly valuable. They are crucial for understanding the full picture. They help us learn about the broader implications of these medications. GLP-1 and GIP agonists were first developed for diabetes and weight management. Finding out that they might also help with addiction opens up completely new avenues. This research could lead to new treatment options for people struggling with various forms of addictive behaviors. It highlights how scientific discovery can sometimes lead to unexpected but very important breakthroughs in medicine. The journey of these drugs is a fascinating example of this process. The Future Horizon GLP-1 GIP drugs in addiction treatment. Looking ahead, GLP-1 and GIP agonist medications show considerable promise. They could become a new and helpful tool in the field of addiction treatment. The possibility that a medication primarily used for metabolic conditions could also address addictive behaviors is exciting. If further research confirms their effectiveness and safety for this purpose, it could offer new hope. Many people struggle with addiction, and current treatments are not effective for everyone. Therefore, having additional options would be a significant step forward. These drugs might offer a novel mechanism to help people regain control. However, it is crucial to have realistic expectations. These medications, if proven effective, would likely not be a standalone cure for addiction. They would not be a magic bullet that solves the problem entirely on its own. Addiction is a very complex condition. It involves biological, psychological, and social factors. Therefore, effective addiction treatment almost always requires a comprehensive approach. This means combining different types of therapies and support systems. A single medication is rarely enough to address all aspects of such a multifaceted disorder. So how might these medications fit into a broader treatment plan? They could potentially help by easing cravings. Cravings are a major challenge for people trying to overcome addiction. If GLP-1 GIP drugs can reduce the intensity or frequency of these cravings, it could be very beneficial. This reduction in cravings could make it easier for individuals to engage with other forms of treatment. For example, they might be more receptive to behavioral therapies or counseling. These medications could support other treatments that address the underlying causes and psychological aspects of addiction. In conclusion, this discovery about GLP-1 and GIP medications is opening up exciting new research paths. It encourages scientists to look beyond their initial applications for diabetes and weight management. The potential to help curb addictions could transform many lives. This journey highlights the dynamic nature of medical research. Oftentimes, the most unexpected findings can lead to the most significant advancements. The future may hold new strategies for tackling addiction, thanks to ongoing exploration of these fascinating drugs. Continued research will be key to unlocking their full potential in this challenging area of health.